What's up, guys? Welcome to another episode of CCT. So today I'm gonna do a problem without rehearsing at all, just try it from scratch. I was thinking of doing an easy problem because I probably won't be able to solve. I don't think I'm at the point yet where I could solve any medium problem, but we're getting there. I've already done these, I guess, so I'm just gonna choose one randomly. I feel like this one looks hard, or out of the easy ones. Merge sorted array. Yeah. Let's try that one. Okay, so merge sort is when you split things up and then you just split things up until they're sorted, I think. I actually am blanking on how you do merge sort though. It's tricky. Given two sorted integers, array num1 and 2, merge num2 into num1s as a sorted array. Okay. And they're vectors. So you have vector 1 and vector 2 and wait, is vector 1 and 2 sorted? Merge into num1 as one sorted array. Numbers of elements initialized in number 1 and number 2 are m and n respectively. You may assume that elements initialized. You may assume that num1 has enough space, and it's greater to hold additional elements from num2. Okay, this makes no sense. This is it's a very downvoted problem. I guess I'll do it anyway. So given two sorted integers, okay, these are already sorted. Okay, this is a good problem for making sure you understand a complicated question. Like this question is clearly not written very well, and you got to be sure you understand the question before you start. Because I don't think this is a hard question. It's just poorly worded. So let's practice that skill. You have two sorted arrays. Both of these things are sorted. You're going to merge the elements in num2 into num1. And we're not returning any vector. We're just putting those elements into num1. We're putting all the elements in num2 into num1. Of course, it's passed in by reference. The number of elements initialized in num1, so I think that means not 0, and num2 are m and n respectively. You may assume num1 has enough space to hold enough space. Okay, so it could be even greater than 3 zeros. There could be even more zeros here to hold additional elements from num2. Okay, I mean, I already have a lot of questions, like, does num1 still have to be sorted? I'm going to assume yes, because then you could just put them all on the end. So that's going to be assumption based on making this problem not trivial. What other questions do I have? So I guess I'll assume these are the ones that are initialized. These are uninitialized, and n is 3 because there's 3 here. But it says that the size of num1 can be m plus n. But it could be greater than that, and it also says, why are they giving us the size of num2? Could this one also not be initialized fully? Okay. I'm just going to assume that this is trying to get us to do a problem that, let's pick this color. That you have like one vector here that's sorted, And then you have one vector here that's sorted. And then you have to merge them together to get here, like this one, this one, this one, this one, like that. That's what I'm assuming, and we're putting them, instead of putting them into a new vector like this, we are putting it into vector 1. So this is like vector 1, which has here, and then these are all zeros, and then this is vector 2, and then it's like, oh, this one belongs in between here, so then let's shift all of these down. I mean, it's not like you could just swap a 0 for these. They're already sorted. Honestly, I think it would be a better time complexity to just make a new vector and then set that vector equal to it. To like do it this way and set like the new vector that we'd make, or set like n1 equal to the new vector that we'd make. Because shifting all of these elements down is like a good amount of time complexity, and I don't think there's any way to just swap anything. Nah. Honestly, screw this. I'm just gonna do vector int results, and then I'm gonna do for, or actually, so int I equals 0. This is going to be going through the first list. Int j equals 0. But I can't, it's not a double for loop, right? It's an m plus n complexity. I have to go through them at the same time and compare the values at each index. And if one's smaller than the other, then I increase j's index like this until I is the next one that should go in this list, and then I increase i's index. So while I is less than m and j is less than n, all I'm going to do is result dot push back. Oh yeah, wait. Yeah, let's do that. Let's be fancy here. So int num gets, so if num's 1 or at I, nope, we can't be fancy. Never mind. If nums 1 at I is less than nums 2 at j, then let's assign num to be nums 1 at I, because we're always looking for the smaller one. And then I plus plus, and then else similar num gets nums 2 at j, and then j plus plus, right? We can move the index going through the second vector through. And then you push it back. Okay, great. What happens if you get through this list fast and you like didn't even move in this one? Well, now you could just add the rest of let's see, like for example, if you didn't even move the ith index, let's just move the rest of them into this vector. So there is pushback nums 1 at I. Yep, and then similar thing for the nums2 list, j is less than n. Let's just do res.pushback nums2 at I. Okay, there's only one thing that's worrying me with this. It's this line. The size can be greater than or equal to m plus n. Like, what? Why? So, like, if there's a million zeros at the end and and like the m and n are still 3, like there's just a million zeros after this. This res, oh, by the way, it should be nums1 equals res, has to have a million zeros also. So you know what I'm going to do? I think there's a way to change only part of the vector. Can you do that like the first? Alright, if I can't do that, then here's what I could do. I can just fill this with zeros. So fill it up with 4 100s. This is the wrong way. Num size of zeros, and then instead of pushback, I do need to control int Dang it, I don't like doing that. But I guess it saves on time too, because we do already know the size, so we technically should be just not using pushback, because pushback takes time. Why does it take time? Because vectors need to sometimes gain space, increase in space. So we always need to do k++. And now the result vector and the nums1 should have the same structure, so this kind of thing can work. Okay, last thing to think about after I do k++, edge cases with when there's nothing in them. Let's see, if there's nothing in them, this size is just an empty vector, and these would both have 0, and then it just sets that equal to that, and it's still an empty vector. That looks good. If it's all zeros here, that means that means m is already 0, so this isn't going to go through, but then this will put the whole second vector in, so it looks decent. I don't think any of those edge cases would fail. What do they want from me? Oh yeah, also j, and we forgot j++ here, and I++. I don't think that's what they're talking about though. What are you talking about? What you talking about? Okay, I have no idea what they're talking about. Oh, I guess it was that. So, looks like this answer is correct. Let's submit. I did this 7 months ago. Cool. Alright, so that's that. You know, I wonder if they cared about those extra zeros. I really do. Or actually, better question, what is the answer to this? If there's just like so many zeros here. Yeah, you are supposed to keep those zeros. Okay, cool. Well, I hope you enjoyed this video. It was probably a poorly written question, but, you know, it trained something. Even the bad questions are good because they help you stay calm and try to really understand the question in the, like, it trains you to truly try to understand the question before you start answering it. And so by doing a poorly written problem, you are practicing your understanding the question part of the interview. And it's a part. So I'll see you next time. As usual, if you have any videos you want me to do, just tell me in the comments, and I'll see you next time. Peace.